Okay, as Alan just notified me, I'm already running late, so I apologize for the 3 minutes delay. Therefore, let's speed this up. If you've been here yesterday, you already met this nice gentleman because he graciously accepted to replace in last minute Gareth Hayes, who couldn't make it to the Hackra track. But today, this is his proper talk that we accepted and that we're very excited about. So this is Erland. He's chapter lead of OWASP chapter Norway. He's mostly developer with a little bit of security, so he's part of the OWASP builders, and this is something that is very close to my heart because I think they are the unsung heroes of AppSec security, because breaking is easy, making its stuff secure is much harder. And therefore, Erland will tell us how to do this.
Thank you. So I named this talk Securing a Modern JavaScript-based single-based web application. And if you're not familiar with what single-page web application is, no worries. I'm going to explain that shortly. So just quickly about me, as Martin mentioned, I'm a developer. I'm also head of the security competency group at Beck, where I work as a developer. I'm the OWASP Norway chapter lead, and I'm also a member of the Norwegian Honeynet project. A lot of these new apps these days are moving a lot of the application logic, especially the view logic, over from the server and over to the browser and to JavaScript. And if we're going to do that, we need to know how JavaScript works. And there are quite a few quirks with JavaScript. These new apps, they rely heavily on it. And some even use it on the server side, like Node.js, like was mentioned in the keynote today. So that makes it even more interesting. So JavaScript, we all know how this works, right? It's 10 million equals 10 million and 1. That's false, right? So it's false, it's false, it's false. What? What's going on here, right? We need to, and this is 3 equal signs, by the way. So this is not like the almost equal, but it's equal, equal. And that's because JavaScript doesn't have like a integer representation the way we think it does. It's actually in the form of a double. So that's interesting. Also, we can do things like this. A equals hello and A equals world, and it will actually do this. How is that possible? Well, we can define an object that has a value of function, and the value of function is used here. So this will alternately return hello and world. So this is a trick I learned from watching a presentation by Douglas Crockford, the guy behind JavaScript. So quite an interesting little thing there. So if we can inject objects like this to the server side, and the server side runs JavaScript, then anything can happen, at least as long as we're using the double equal sign instead of the 3 equal signs. So a single-page web app, what is it? Well, basically, the browser loads a single HTML file, and that file contains no user data. It's just an HTML that loads some scripts and some CSS. And that JavaScript then starts loading the user data. So there's a clear separation that you can see on the left here. We have a web layer that only serves things like CSS, JavaScript, images, etc., all the assets. And we have some services that normally produce JSON, which provide the actual user data. And you can actually split this in half, and you can move all the things on the left. You could put that on a CDN, because there's nothing there that's specific to the user. And you can cache it, even though it's delivered over HTTPS, because, again, there's no user data. So only the services, the JSON stuff, that's the things you shouldn't cache in the browser. And you can do navigation without reload. Instead of loading HTML fragments that contain user data, you load HTML templates and you merge them with user data. So you're using some kind of a templating framework. State, where you're at in the application, is often maintained by hash URLs. So something like this. So instead of an actual URL, there's this hash sign, and there's a bit to the right that allows you to do bookmarking and things like that. And if you open the URL, it will take you to that point, even though it's some part of this is not sent to the server. Everything after this hash sign is not sent to the server, so the server doesn't know, but it's bootstrapped on the client side. a new feature is pushed out to the browser, which is called push state, which actually allows you to change the URL without a reload. But I'm going to mainly focus on this part in this talk. And JavaScript templating, as mentioned, it's a mix between JavaScript and HTML. They are typically compiled on the server side, but they can also be compiled on the client side. It's faster to compile them on the server side because then you can pre-compile them and deliver them out to the client. And there are millions of types of templating languages these days. Here are two examples. One is underscore, the top one, and the other one is mustache. And what we see here is we have some JavaScript in here, and we have some output here. And so it's sort of a mix, and this gets compiled into a function that you can call with data, and then out comes HTML. So I'll show you just an example of such an app. So this is a discussion board. So I can navigate between categories. It's just really fast because there's no page reload. You can see the URL is changing all the time when I'm clicking around here. You can also see an attempt to do cross-site scripting here, which didn't work. So yeah, this is the underscore templating framework. So there are basically three types of functions that you can use. You can use one to evaluate code, like do for loops and things like that. There's output, and then there's HTML escaped output. And HTML escaped in this sense is contextless, so it's not perfect. But I'll come back to that later. So when we're looking at these kinds of apps, I like to use something I call domain-driven security analysis, which is a term coined by Dan Berg-Jonsson and John Wilander, which basically says that we have, of our data, we have different models represented in the different kinds of system, or different parts of the system. And often vulnerabilities occur when we're moving from one representation of our model to another. So as an example, we have a database. And of course, we're talking to that database using SQL. And then we have some kind of a server, a Java server or whatever, where we have server-side object. And of course, SQL injection occurs when we're moving from the server-side representation of our model and into SQL. That's when we're breaking stuff. But I'm not going to focus that much on that because that doesn't change much from a single-page web app to the standard web platforms that we're used to. And this is where a normal old-style web app would produce HTML. But these new apps, they provide JSON there instead. So the data that we have on the server, they're transformed into a JSON representation, and they're moved over to the browser. In the browser, we're running JavaScript, and the JavaScript is using these templates and produces HTML. So there are multiple places where we're transforming from one representation to another. So to explain the part about having different representations of the same object, we can think about, let's say, a user account. In the database, that would be a table with strings. On the server side, it might be an actual object. In JSON, it's, again, strings with some commas and quotes and things like that. Then in JavaScript, it might be some kind of a JavaScript object again, and then we have HTML. So there are multiple representations of a user account here. It could be on Twitter, you're logged in as Web2Null, which is my Twitter handle, or it could be the profile page where you're viewing your profile. So that's another representation. And it's sort of when we're moving from JavaScript and onto these different representations of our model, that's when cross-site scripting happens. So it doesn't really matter if it's from the server to HTML or it's from JavaScript to HTML. It's still the same problem. We're moving from one representation to another, and we're not doing it correctly. So, of course, client-side validation is something we all know that it's not really a security measure. It's more of a usability thing that we can provide feedback. And there are so many ways that we can circumvent it. We can change the HTML, we can change the JavaScript that's running in the browser, we can use a proxy, we can change the request in the proxy, we can change the response in the proxy, and we can directly attack the JSON service, because now we can just simply disconnect ourselves from the web app and just go directly to the services. So I'll show you one example of that. There's this great tool in Chrome that's called Postman. So let's look at the profile page here. There's an email address field here, and if I try to enter something that's not valid, it goes red, and I can't submit the form. It says, please provide an email address. But of course, I don't have to use this form. I can go directly to the service. So this is Postman. It's a tool developed for developers who want to see how their JSON interfaces work and then play around with them. So it works well for security as well. So I can send a GET request. The GET request is set up here towards this URI, and I get the representation of my current profile. And then I can just say, I want to change one field. So now it says email garbage. And if I go back to the app and I reload the page, it now says garbage. And now I can't submit the form anymore because it's invalid. But that's just an easy way to circumvent it. And we all know how this works. Another thing is what I call promiscuous services. Now we're in the state where we're moving from JSON and on to the backend server or the other way around. So promiscuous service is basically a service that's either showing too much or allowing others to touch their privates, which is a bad thing. And the first thing that we will talk about there is mass assignment or overposting. It has multiple names. So we can change things that we're not supposed to be able to change through the UI. We can send a JSON request with unexpected fields. And I mentioned this yesterday, but Egor Homakov did this on GitHub. If you look at the text here, it might be hard to read from in the back, but it says Homakov opened this issue in 1001 years, so way into the future. And it says, I'm Bender from future. Hey, where's the suicide booth? And this created quite a lot of stir at GitHub, and I think he was kicked out and later allowed back. And of course, this is really simple. Again, I'll use Postman. So here's a message that I've posted, and there's a lot of information about this post, like who wrote it, the body and the text, etc. And there's a created at field, and it now says 2013, August 9th. So let's just change that date to say 2000 instead. So now in the response, it says 2000. And if I go back to the web UI, the post was now created in year 2000. So it's really a simple attack. If we're not filtering what's coming in on the server side, this is what will happen. And there's another thing here as well. We have user accounts here, users that have been posting the messages. And there might be some issues there as well. If we're simply porting what we have on the server onto JSON without any filtering of fields, we might be showing too much stuff. So let's see what really lies behind these requests that are showing posts. And let's filter it on XHR, and let's look at messages. So a message has a body, and it has some other interesting stuff, and it has a user who actually created it. What's this? Password. The password hash was leaking out because there was no filtering of fields. We simply took the model that we had in the database or on the server and made a JSON out of it. That's not a really good way to do it. So how do we fix this? Well, we need to limit the exposed fields in the responses. We need to ignore unwanted fields in requests. And the best way to do that, I find, is to build a separate layer on the server which defines the contract of a REST API. So that layer of objects is what we're creating JSON from and to. And then we have a very clear idea of how we're moving back and forth between our internal and external objects. And we can very simply make sure that things are working the way we want it to. We can change things internally without breaking our API, and we can have multiple versions of our API in a really easy way. The next thing is overconsumption. What happens if we're posting like a big JSON document, much bigger than is expected, and we're using like a NoSQL document database, and we're simply just taking the JSON and pushing it into the document database? So we can send like really huge documents, and the maximum document size for MongoDB is 16 megabytes. So you have a user account that's normally like maybe 4K, and now it's suddenly 16 megabytes. And the database will just grow, and so where did your disk space go? That's not a nice place to end up. So we need to think about what fields do we allow in, even though we're not using those fields for anything. If they're taking up space, they're not really useful to us. So strip unwanted fields. Use a whitelist. These are the fields I want. All the other ones I'll just throw away. Cross-site request forgery is also an interesting attack on these kinds of systems. Because even though the HTML is built on the client, we can do CSRF directly towards the JSON services. We all know how CSRF works, like there are GET requests using image tag or POST requests using hidden forms. There are actually ways that we can use this to build JSON requests if the server is not configured correctly. And this kind of attack has, of course, been used to change DNS of home routers, etc., post to Twitter or Facebook and things like that. CSRF in general, I mean. So here's an example I stole from John Wilander. This is a form. It builds a JSON object in here, and it says the name of the object is some JSON, and then the value ends the JSON. And what that becomes when you post it is something like this. So you see, it inserts an equals sign right here, because its name equals value, but it becomes a JSON, and you have to set the encoding type to text plain. And of course, if the server doesn't check the incoming data type, if it just assumes that it's always JSON, then it will accept text plain and think that it is, in fact, JSON, and render it as JSON, and yeah, there's a CSRF problem. Another way is from Koto, which is a way to post files using, well, basically using JavaScript and building a request and posting it to the server. Very interesting attack. And the interesting bit is that we can test our JSON interfaces. The JSON interfaces are supposed to be stable. If you're a developer and you've written web tests, you know that that's a big problem, because the website is changing all the time, the tests break, and you're really not getting all that much good out of it. But if you're testing a JSON API, it's supposed to be quite stable. So it's easy to test. And you can write real tests that are booting up an HTTP server and actually running these requests. So you can test CSRF protection, input validation, data exposure, mass assignment, etc. You can test all of these things and make sure that you don't reintroduce problems later. And when I was doing research for this, I discovered kind of a new type of CSRF, which I dubbed CS#RF, because it's somewhat different from the normal CSRF attacks that you see. And the problem occurs because we're using these kind of JavaScript frameworks. So if a hash change, just simply changing the URL, makes a change of data in your app, you have a problem. So in this URL, we're just opening a presentation from a conference in edit mode. That doesn't change the data, so that's okay. But if a hash change will actually delete something, then we have a problem. And this actually circumvents normal CSRF protection. So let me show you an example. On this board that I've created, we have a like link here. And behind that link is just a simple URL change. So if I want to attack this site, I can simply create an iframe or a new window or something, and then open that URL. It doesn't work for image tags because it has to be an HTML frame where it's actually running scripts. So if I now post this link, and something happened, and then it went back. And that's because the JavaScript on the page is doing a back to take you back from where you were before you clicked the like link. So if I go back to the actual server now, we'll see now I like this post. And all I did was open a URI. So any page could include this URI, and it would actually work. And the interesting bit is, if we were to look at the requests that were behind this, let's do it like this. I think I have to actually store the request. Well, see, it does a post to likes, and there's a CSRF token included in the requests. So it's actually doing everything it's supposed to do, which is the problem here. Why is this happening? Well, as I mentioned earlier, having these kinds of URLs are there to allow you to bookmark. So when you open the URL in an iframe or a new tab or anything, the JavaScript framework does bootstrapping. It does everything it's supposed to do, loads your user profile, all the HTML templates, the CSS, etc. And then it looks at the route and it says, I'm supposed to go to a place where the user likes this post. Okay, I'll do that. And then it posts the request back to the server. So it processes everything the way it's supposed to. And of course, then the thing it's supposed to is to include the CSRF token in the AJAX request. So it does that as well. So it circumvents the entire normal way that you do CSRF protection. How do you protect against this? Well, a hash change should never cause changes on the server. That's simply the way to do it. So you can think of this like get and post requests. Only this time it actually works. Never have a route change, a get request, cause a change on the server. So if you're going to have like this delete, then that should bring up the actual delete pop-up. And when you click that, you do some magic behind using normal jQuery or something, not just change something based on a route. So that's most of the attacks that I've looked at that are referring to like the JSON API and how attacks can occur like that. The next thing I'll talk about is cross-site scripting. We all know how reflected cross-site scripting works. There's one interesting bit, like reflected cross-site scripting normally occurs when the server is returning HTML and there's something in there that's breaking. But there are some tricks that we can use. Like these are the normal kinds of cross-site scripting where you include something in your URL, it comes back, and then there's something going on here that's not good. And the same thing for persistent cross-site scripting. There's also something similar. You post something and you get something back, and there's a problem there. But something can occur here that's not really intended, and this only works in older browsers. So I have a version of IE9 here. What happens if I try to load the JSON directly in the browser? From the other window here, you could see that I had tried to do a cross-site scripting attack, and it didn't really work because it was doing HTML escaping. But what happens if I try to load this directly as JSON? And then I try to trick the browser because I add .html and try to trick the browser into thinking that this is actually HTML. Oh, interesting. So now it's reading JSON, but it thinks it's HTML. This is fixed in IE10 and the newer versions of IE, and it's quite easy to fix in older versions as well. It's kind of an old exploit that a lot of people know about. What you can do is you can set some headers, and what we talk about then is content sniffing. So you can tell the browser, no, don't try to second guess me. I'm telling you this is application JSON, don't think it's HTML. And that will actually solve this problem altogether. And this feature, it's understandable why it's there, because back in the days of when the web was young, servers would never deliver the correct content type. They would deliver everything as text HTML or everything as application octet stream. So the browser would have to look at the content and to display it correctly. But, so this is quite easy to fix. All we have to do is to yeah, I've already said all this. So the thing we have to do is we set a header that says X content type options, no sniff. So now the browser will stop this. What we could do also is we can say, if you're trying to download the JSON directly in an iframe, we're going to prompt you for download. So we can set the content disposition header and say, this is an attachment and the file name is data.json. We can set that for any resource because it doesn't really matter. When you're doing an XHR or an AJAX request, it will simply ignore this header. But if you're trying to open it in an iframe, then it will pop a download dialog instead of just showing it. So that will also work. Yeah, we all know how stored and persistent cross-site scripting works. This was actually a stored cross-site scripting, the thing I just showed you. And then we have DOM-based cross-site scripting. It occurs in JavaScript, not necessarily visible at the server because the attack can be a part of the hash. Here's an example I found online. There's a Twitter user called Lisher or something. He found an attack on x.fm. And it's basically insecure handling of input in JavaScript. And there are a lot of sources for this kind of XSS. These are borrowed from the DOM XSS wiki. There's going to be a talk about this later today by Stefano Di Paola, so you should really attend that one if you think this is interesting. There are a lot of other functionalities in JavaScript as well that can cause JavaScript to pop, like links where you put JavaScript colon and then some JavaScript, or redirects, or all kinds of things that insert HTML. And you also inner HTML with Mario yesterday, I hope. That was scary stuff. And then, of course, there are unsafe functions in the libraries as well, like in jQuery. All of these will insert HTML directly without no escaping. So can be kind of scary. And I often see developers are using these, especially .html, all the time, which is bad. So the safe ones are .text and .attr, unless the attribute is actually a JavaScript event handler. But those can be used safely. Those do proper escaping, or they insert it into the DOM, so it's not really escaping. There's also a tool called the jQuery encoder, which does have some JavaScript encoding things for encoding for CSS, encoding for HTML, encoding for HTML attribute, et cetera, et cetera. But I prefer to not end up there. And then there's the HTML JavaScript templates. We need to check when we're using one of these templates, what kind of output does it do? What kind of coding options does it have? Does it escape input? What kind of escape? And is the escaping context-based? And I mentioned this earlier for underscore. It does have evaluate codes, output, HTML escape, output. And the escaping here, what it's doing is replacing the ampersand and the less than, greater than, quote, single quote, and the slash. So, okay, so it's doing quite a decent job for HTML escaping, but this is all well and good as long as we're not outputting data inside JavaScript event handlers, because then the escaping will be ignored, or actually it will just be a part of the attribute. As long as we're not using quoteless attributes, because it's not escaping space, so you can run along. As we're not outputting data inside style attributes or tags, not outputting data inside script tags. And of course, there's the OWASP XSS prevention cheat sheet, so go look there to see how to test this. I did an experiment. I tried to create a very similar framework to _JS templating. I called it Helmet.js, and I hacked it together 2 nights or 3 nights. And I put out a challenge. So you can find it here. So I did evaluate code, unescape raw output, and then contextually escape output or refuse if it's an unsafe location. And then I created a playground, and I posted it to Twitter and said, hey guys, do you want to test this? Can you find any bypasses? And of course, people did. This one is quite interesting. This was the template he provided. And it says age aref equals, and there's a quoteless attribute. And then title equals buy number at price at cost per month, and save dollars by now. And the data he provided was an empty URI, the number 42, the price on mouse over, and the cost equals alert 1 slash. And what happens is really strange, because the href doesn't have a value, it pulls together the next attribute, which is title, as the value. So it actually takes this attribute and this attributes and merges them into href equals title equal by. And then 42 becomes an attribute on its own, at becomes an attribute, and on mouse over, and then dollar equals alert 1 slash slash commenting out month. So it's quite a clever attack. And this was because of quoteless attributes. And you can probably guess the next one. It's SVG. Who is behind this one? Mario, of course. All he did was have a tag that sets an attribute on another tag. And of course, there's JavaScript involved, so that would just work because I hadn't thought of SVG because that's so complex. And I kind of agree with Mario, just don't use SVG with dynamic data. Just don't. So that was my attempt, my really quick attempt. It kind of works, but I'm not sure it's production ready. I wouldn't use it in production right now, at least. And one of the things that you can use to mitigate some of these problems is the content security policy. There has been talks about the content security policy at this conference, where we can define it's actually a standard now, not an upcoming standard. We can define where we allow script to come from, how we allow it to run, et cetera, et cetera. And this, by default, allows unsafe versions of evals, set timeouts, set interval, et cetera, and will basically stop some attacks. It also disallows inline CSS and JavaScript, so many of those attacks wouldn't work either. Yeah. It's currently supported in Chrome, Firefox, Safari, and Opera. I'm not sure about IE when it will come there. There is a testing tool that I built that you see at the bottom here, csptesting.herokuapp.com, where you can test your browser's compliance with a lot of the different CSP rules. I need to add some new tests there after hearing about some of the attacks at this conference, though. There are some other attacks as well that we could use if we allow JSON to be displayed in iframes. We can do drag and drop clickjacking, which Koto has been doing. We can fake captchas. I've seen attacks there as well, where you show a part of the JSON in a small area or a small window, and you say, this is a captcha, please enter the code above. And that's actually the CSRF token, so you trick the user into revealing their CSRF token. And there's, of course, Paul Stone's Ninja pixel stealing stuff that he showed yesterday at the HackPro talk, which was just insane. You can steal the contents of the JSON by SVG filters and stuff. It was a very cool talk. So protection, well, we can say JSON is not allowed to be showed in iframes by using xframe options, or we could use what I said earlier about using content disposition attachment file name. So it won't show in an iframe, it will pop a download dialog instead. And then there's server-side JavaScript. Oh, what if you're using eval on the server side? And that's so much worse than SQL injection, because now we actually have direct remote code exec. Yeah. I'll show you a quick example of that as well. This is a demo that I, copied from, I think it was Brian Sullivan. There's a simple system for checking a stock quote. So if I check for OWASP, it doesn't really check for anything in particular. Okay, I get back. OWASP past the current value is 99. And what it's doing is it's sending a JSON. So you can see it down here. It says symbol, let's look here. It's posting symbol OWASP, and it receives back some information about that. But the fact that it's posting a JSON is something that we can abuse. So I'll show the simple attack here. I have some more interesting attacks as well that I could show you later. What happens if I were to do something like this, and the browser is not doing proper escaping? I could do it using Postman as well. Let me just find the zoom here so we can. So I'm breaking out of the JSON, and I'm doing a while one. And I'm sending that over to a Node.js backend that's using eval to parse JSON instead of using JSON.parse. So, nothing comes back. And if we look at the server, we see Node is running at 100% CPU. And you can use this to do lots of worse stuff. This was a simple DOS attack, but you can read any file on the server. You can do any kind of havoc. So be careful with eval. Eval is evil, remember. Oops, I guess I need to change the zoom. See. There we go. So, some final thoughts. In the OWASP Top 10 2013, there's A9 using components with known vulnerabilities. And this, of course, applies to these kinds of applications as well. If you use a framework, a JavaScript framework, keep it up to date. Security flaws are discovered all the time, and they might be discovered at a later time, like happened to Yahoo. On the 13th of January 2013, they were using a library called sesvars.js. It had a security update back in 2008 because there was some eval mess inside there. And they hadn't updated it, so they basically had remote code exec. So that's it. Any questions?
So first, thank you, Alan. So the floor is open for your questions. So, well, actually, I have one.
Yep.
So you said eval is evil, and so I'm only a security guy, and I know this eval is evil. And what always makes my head scratch is, what is the purpose of evil? Why are people actually using this? And so probably in your position as both the developer and security guy, you saw reasons why this would be used.
Actually, for compiling these templates, the JavaScript templates, eval is often used. What they're doing is basically finding the locations where there's JavaScript, and then they're building a function of that while using new function with that as a script, that script inside as a string. And that builds a new function. And that's actually a safe way to do it because you are in control of the template. There's nothing wrong with that. And as long as you're doing it on the server side in the pre-compilation phase, that's quite okay. But that's a use of eval where you can see it's useful. I'm not sure why it's in there to be used for a lot of other things, because it's, at least never use it for parsing JSON like people used to do. And I think some client-side libraries, at least the older ones, do that still because the older browsers didn't support JSON.parse. That really quickly becomes a problem. So building code from strings can be useful, but it's not necessarily something you want.
I agree. Good. So then you have a couple of minutes to change the rooms, which I don't recommend because we have coming up Dave Ross.